In this video, we're going to look at function operations. And for our various examples, I will use two specific functions, f of x equaling 2 minus 3x, and g of x equaling x squared plus 5x. We'll begin with our first operation of addition, where you go f plus g, all in parentheses of x. That really just means you're going to take the f of x function and add it to the g of x function. So if f of x happens to be the quantity 2 minus 3x, and you add it to the quantity of x squared plus 5x, or g of x, you'll want to combine like terms. And in this particular case, the only like terms that I see are negative 3x and positive 5x. And when you put those together, you come up with, if you write it in standard form of course being largest degree to smallest degree, in this case constant, x squared plus 2x plus 2. We'll move on to the next operation, which is subtraction. Really, it's not going to be that drastically different, but there is still a key difference. If you are going to subtract f by g, remember to use parentheses. It's imperative that you remember to use parentheses because this negative needs to be distributed. You need to take the negative x squared and a negative 5x to produce those terms. Many students are quick to do the negative x squared, but fail to actually distribute it over to the 5x. Then when you find your like terms, which in this case is negative 3x and negative 5x, you can come up with an answer that is negative x squared minus 8x plus 2. The next operation we'll look at is multiplication, in which f of x is multiplied to g of x. If we use our examples from the upper right, we will need to take the binomial 2 minus 3x and multiply. But let's be clear here. Actually, what we're going to do is distribute, as in the distributive property, over the other binomial, x squared plus 5x. A binomial times a binomial had a cool little acronym you might recall. We call it foiling. What does foiling mean again? Well, foiling means F for first, O for outer, I for inner, and L for last. Well, let's go through the process and show you how we come up with the first terms. That's where you go 2 times x squared, because each of those are the first terms of each binomial. Then if you take the outer terms of the binomials, 2 times positive 5x, that's how you get the O. The inner would be the two most inner pieces, which would be negative 3x times x squared. And then finally, your last terms of each binomial, that's negative 3x times 5x, is how you get the L. And when you multiply those together, you'll come up with 2x squared plus 10x minus 3x cubed minus 15x squared. Take the like terms, 2x squared and negative 15x squared, combine those, and you'll come up with negative 3x cubed minus 13x squared plus 10x. The last of the four basic operations is division, in which f of x is divided by g of x. But division has some major concerns, and one of the most basic concerns is that you cannot divide by 0. So we have to make sure that whatever we do, we cannot allow g of x ever to equal 0, otherwise it's going to cause problems. Another problematic area is when students try to simplify a division problem. For instance, if we had 2 minus 3x all being divided by x squared plus 5x, I could see some students trying to cancel out the x's. That would be incorrect. Not all the terms have an x. In this particular problem, this is already simplified. If 2 had an x, well then we could cancel an x from everything. If all the numbers were even, we might be able to cancel 2. But there's no common factor besides 1 in the numerator or the denominator, so we're just going to leave it alone. Now the reason I wrote the x squared plus 5x is not equal to 0 is to take into account I cannot have g of x equaling 0. I need to remove the numbers from the domain so they'll cause issues. And speaking of domain, you have to understand that it doesn't matter which of the operations. If you have a sum, a difference, a product, or a quotient, the domain consists of the x values that are in the domains of both f and g. And both f and g in our examples are all reals. But we have to also remember that we can't divide by 0, and so therefore we will have to remove any values of g of x, where we, in this case, would cause it equal to 0. So let's analyze that part right now. When would I have a denominator x squared plus 5x equal to 0? So Using some factoring skills, I can pull out the greatest common factor of x. That would be multiplied to x plus 5. If you recall the zero product property, you cannot have x equal to 0, and you cannot have x plus 5 equal to 0. Well, x can't equal 0 at 0. For the other part, we'll subtract 5 from both sides, and we'll realize that not only can x not equal 0, but x cannot equal negative 5. So when we define our domain, we need to remove those values. And in set notation, I can just say x does not equal negative 5, and x does not equal 0. The and is important because we need both conditions. If we choose to use interval notation on the right, you'll notice that I write the first interval from negative infinity to negative 5. Because of the parentheses, I'm intentionally not including negative 5. But I immediately have to connect it. That's a little union symbol right here. That just means a union, where I connect it to another interval of negative 5. But again, I don't include it. So in some respects, if I was drawing out a number line, I would have it going filled in completely to here. Then all of a sudden, this would be negative 5. It would be a hollow dot. I'd be drawing it to 0. All this would be filled in. I can't include 0 with the parentheses in either side. And then I just continue on filling this all in until I get to infinity. And so that would be the number line, which is nicely represented by the interval notation, or if you want, the set notation as well.